Hello guys, I am Ali Jawad and welcome to my YouTube channel. In this video, we will start with chapter number 7, Pressure of Cambridge Cables Physics 5054 for O-level students. So, those who are new to the lesson, they are requested to go for lessons on forces which encompasses the chapter kinematics and dynamics so they may have a better understanding of this topic. Let us start with the definition of pressure. Pressure is defined as the force acting on a surface or the force acting in a unit area. It is a scalar quantity, means it does not need to be specified direction for pressure, and its formula is given by the equation force upon area, and its SI unit is Newton per meter square. We can directly derive unit from its equation. The SI unit for force is Newton and the SI unit for area is meter squared. This is equivalent to another SI unit which is known as Pascal. Now, if we may look at this formula, this is actually representing a force distribution. What do I mean by force distribution is that whenever a force is applied on an object, let's say if we have a plank or a flat surface like this, and if we are applying some force on it, so the force is distributed on each part of this object. So pressure is actually the term which tells us that how much force is being acting on one point of this surface. Let us understand with the help of an example. Let's say if we have an aquarium like this, which is filled with water. So the weight of the water will act on the base of this aquarium, and all the weight will not be acting on a single point. Obviously, this portion of the water has some weight, and this weight will be acting over here. And this portion of the water will have some weight, and this weight will be acting over here. So it means that the overall weight is distributed along the surface, which is calculated by force divided by area, that how much newtons are acting in 1 meter squared area of the surface. Let us also try to understand pressure with the help of some more examples. So, if you will try to apply the force on the sharp end of the pin, do you feel a pinching effect? Yes. And it is because all the force is concentrated into a single area, which is a very small point. So, as you can see by the formula, as the area reduces, the pressure increases because pressure is inversely proportional to the area, and that is why we feel a pinching effect. However, if the pin is pressed against the finger from its blunt end, then we do not feel the pain or pinching effect, and that is because as the area increases because of this flat head, the pressure decreases because of inverse proportion, and when less pressure is there, we do not feel pain. This is one of the good examples to understand the direct and inverse relationship in this formula. Let us go for another example. The weight of a person who is skiing on the snow is enough so that the feet of a person may sink deep down into the soft snow. But ski helps us and does not allow the person to sink into the snow. And how is that possible? Because ski receives the weight of the person and distributes it in a flat area. So each part of the ski receives a lesser amount of force than compared to the weight of the person. So ski actually increases the area of that person instead of its feet. The larger area is there to support him. And when area becomes large enough, so the pressure decreases according to inverse proportion relationship, and the person does not get deep down sink into the stone. The same principle is observed in different animals which are found in nature. For example, the sand of a desert is also soft, so the feet of the camel can sink into the sand, but the larger area of the feet enable the camel to walk firmly on the sand without slipping, because when area increases, the pressure decreases, and that is why camel's feet does not sink deep down into the sand. So I hope you have enjoyed the lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching.